Okay, so today I'm just going to be going over quick and simple the first part in how to build a custom vector, explaining what all of the different parts do. So I'm going to be building this as we go along, and there's probably going to be 2 or 3 parts in total. The entire code base comes out to around 400 lines, but it is quite densely packed with a lot of repetition. So let's just get started. I'm currently in a completely clean environment. Let's just go into vector.h. So a couple of the includes that we're going to need are going to be cstring, iostream, probably assert, iterator, and exception handling. But for right now, I think all we really need is including cstring, iostream, just for couting, iterators, because iterators, and then exception handling for all of the different errors that can happen when you make a vector. Now, you could just go all out and just include bits std c++.h and also include cstring, but that would defeat the purpose as you would then be including STL. I'm going to go turn off the volume on the Windows terminal, which is one of the big gripes I have with it. So at the very beginning, what we're going to have to do is we're going to have to template. And so what a template allows you to do is instead of saying that you want a vector of int and then making one for vector of ints and then one for vector of chars and one for vector of doubles, templating allows for variable typing. So for example, vector of int versus vector of double, vector of custom type, and finally it's vector t. So this is why we're going to need to template it. So the entirety of our vector is going to be within a class, and I think that would be pretty self-evident because we're doing this in C++ and not C. Doing this in a class is definitely the better way to go. If you were to do this in C, I'd imagine you could most likely do this in a series of defines and just a large function, but I would not want to go that route because we have the tools given to us by C++. I'm going to make use of that. So let's just class vector, and that's the beginning of our vector. So there's a couple of things that we're going to want to define before we get ahead of ourselves. One of the things is going to be the actual underlying array, because a vector is nothing more than a dynamic array, right? It's a dynamic array. So that means that we need something that's an array. So what we're going to do is we're going to make a T star that's called array. So what this is an array of type T, and it's an array because it's a T pointer. This will allow us to create variable size memory, reallocate, allocate, unallocate, delete, all of the good stuff that we'd expect. We definitely don't want to make this public, so we're going to be making this underlying data structure private alongside something that we're going to be calling a reserved size. So a reserved size will be how much size does the vector have such that if we were to emplace back in place and we had the extra elements, it wouldn't be adding an extra element. This is very important because it's not the same as the actual size that you're asking for when you call vector.size in C++. So those are going to be our 2 private members that we're talking about as so far, but we're going to move on to our publics right now. And I think the very first thing that we need to talk about is just a super simple initializer. So we're going to vector with absolutely nothing inside, and we're just going to create it. So we're going to make our array equal to a reinterpret cast, of a t star with an array. And don't worry, I'm about to explain this. So what this is doing in totality is this. We know we need an array, right? We also need to have some size. Currently, our reserved size is 0, so just think of this as 0. Size of t is extremely important because if we're given a size of, let's say, 20, whatever t is, if it's 20 large, it's very important in both mallocs and when you're creating arrays to make it of that size. Right now, we're creating an array, a new array within this that's size 0, basically. And we're reinterpreting casting it to t star because what this will do, and this will allow us to do, is because chars are each 1 byte, we're going to give it that amount of memory and then chunk it. So, for example, an int is 4 bytes. So you have int, int, int. If you had 3 ints, you'd have 12 bytes. Right now, what we're doing is we're creating a char array that would have been size of t, which is 4, and a reserve size, which would have been 3 for 3 ints. We would have created a char array that was 12 bytes long, which therefore would have been able to be split into 3 4-piece chunks for our t array, which would have been int. That's why we're doing it in terms of char. It's kind of confusing in the beginning, but you'll get used to it pretty quickly. It makes life a lot easier to work with chars when you're actually creating stuff. In addition to what I've written here, we definitely want this to be an easy method. We never want this to error out because basically everything in it has been defined for us. So we're just going to no accept. So now what I'm going to talk about is a destructor because I just showed you how we're going to construct something. We also always need a destructor. Now, don't worry, we have around 7 or 8 more initializers that we need to make for vectors, because if you've ever worked with vectors, you'd understand exactly how many different ways there are to initialize them. There are a lot. So we're going to create the destructor. For some int I0 till I the size of vector size, which we will now turn into another private member, vector size. I is less than vector size, plus I. And then what we're going to do is we're going to call the destructor of the specific element itself, such that we create array, or we call array at I, array at index I is a key element. So what we're going to do is we're going to call a key destructor. This will allow us to destroy every single thing that's in the locations, and then we're going to destroy the array itself. And how we do that is we delete the array, which we are then going to reinterpret cast back to a char star of array. What this will allow us to do is, instead of going int by int, we turn that entire t star array, which was initially chunked from a char to a t, we're going to return it back from a t to a char so that we have all 12 bytes in our example program and delete that entire array. Because remember, chars allow you to interact directly with memory because of 1 byte to 1 byte. It makes it a lot easier. This is why we're going to be doing it in this manner. So now that we have an initializer and a destructor, you might think, okay, so I can just add in pushback and stuff. But that's not really the case with vectors, because if you've ever read through STL documentation, you'll see that not only are there numerous overheads, there's just so many fallback initializers, and you need to create most of them to have anywhere near a helpful implementation. And I'm going to go through one of the easiest ones that you can create, which is just a simple initializer, place it vector, which is going to take a number, and this is akin to writing if you remember, std vector int a5. Does that make sense? This is basically a vector of size a, or of size 5, that is going to be called a. Now we can also do 5 comma 3 and then make it of size 5 filled with 3's, but that'll be for the next one. Right now what we want to do is we want to be setting which one? The reserve size or the vector size? Right now we want to be setting actually both of them. So reserve size, and remember the colon with the member variable name here is another way of setting it equal in C++, and it makes life a lot easier. So reserve size we're going to be setting to n, and we're also going to be setting vector size to n. Now, given we've done both of these things, the rest of it is pretty self-evident. We can go back and just take what we have here and then we have to do a secondary thing, which is just for uint I equals 0 while I is less than n, or while I is less than reserve size, or I is less than vector size, it's all going to be the same thing, plus I. New array plus I t. This creates keys at every single area, because remember, when you create a vector with a given size, that area of memory is accessible immediately. For example, if I were to do vector int a 5, I could then immediately do vector 3 equals 7, because it's assumed that I can index into that memory location. With a regular vector initialization of std vector int a, this is uninitialized memory. You can't do that. So what we do here is we actually initialize with different t initialization, such that we can index into them at a later point. And that's why it's very important to have different initializers all over. It seems like a lot of code duplication, and a lot of the times it is, but we must do it. Otherwise, there's no real better way to do it. Because when it's the same line over and over at the beginning without any change, even if you made a function for it, sometimes it does tend to change minutely. So I prefer to have it the same way every single time. So next, we're just going to be making another quick vector with a uint n and a const t and val. Now, this is the situation that I was just speaking of, which is std vector in a 5 comma 3, where you're filling. Now, filling is very important. A lot of the times we use this as a method of fill with zeros, fill with ones. A lot of the DP programs that most people who have been taking interviews recently are very familiar with require you to fill with some such number. And without that, your life will be very, very difficult indeed. So now what we want to do is we want to take the exact same thing, but now it's exceedingly simple if you think about what you're going to be doing here. We're going to do the exact same thing that we just did for uint I equals 0, while I is less than n, plus I, and we're going to new, oh, where am I? Oh, because I'm tapped in, that's fine. Array plus I, t, but initialize t with val. That's it. It's that simple because we're just giving it a value. That's it. Next, what we want to do is we want to be able to create a vector from another vector. And that's simply vector given a first and a last iterator, So vector const t star first, t star first, const t star last. All this is paste, as usual. Now, what we do is for uint I equals 0, while I is less than vector size, plus I, plus first. Because if you've ever done any string manipulation or C string or work with any char stars, you understand that just iterate from first to last. We can continuously move. What we're going to do is t star temp equals reinterpret cast t star array plus I. Because what we're doing is array is always the first element. Because if you write a char star x and you just give x, x is the first element. If we're adding a certain number, that's an offset. So it's index 0 for 0, then 1 for 1, 2 for 2, 3 for 3, so on and so forth. Given this, we're able to then write new, we should probably do that. Then we new temp t star first. So all this is getting the value at that location, because there's the location that we're talking about, there's the actual value that we're looking at that location, and then we go ahead and we push out, because first is being continuously iterated forward. We're going to be looking into it, and as it moves forward, instead of the reference, it moves into the value, and we're going to be doing a new temp, which is the place in the actual array that we have, and we look into the other one. Quite confusing, but I think it's not the worst thing that you could look into or that come up in terms of this code base even. That would definitely be reallocated, which is going to be much, much later. An easier one is just a vector initialized with a std initializer. This one's extremely important. It's minimal use of the STL, but I believe that allowing for other STL objects to interact with this is actually quite important, because without this, you get a lot of problems. An initializer list is something such as this. This is like std vector int g equals, or g equals 4, 5, 6, 7, 8, something like that. That's not really initialization, but you can understand what I'm talking about here. It's this kind of idea. So now we want to reserve size. Oh, have I been writing reserve size? Yes, I have. Not for this. That's fine. Let's just reserve size is simply the pointer diff t between last and first. And vector size is nothing more than reserve size. Because remember, pointer differences will give you integer value between pointers, because you can add and subtract like ints. So given an initializer list, we actually only have a reserve size that we're going to be creating here. We're just going to reserve size of l.size, and then we're good there. So same, of course, array. But here the difference is we're just going to auto through the list, and we're going to, and remember, auto and v in L is just the auto reference v from within L. In Python terms, think about it for every x in y. It's just actually taking the element out rather than referencing it. We're just going to new array plus vector size t v we're going to go ahead and also increment vector size. So in this way, vector size only ever reaches L size because in the beginning it's 0, as we defined it to be, and it's 1, 2, 3, all the way up to the actual vector size. This is the reasoning I had behind not initializing it here. Rather, we're going to be iterating anyways. Why not use it as an iterating variable and save us the cost of having some int just laying around to be deleted? Let us look at another quick one, and this is the last one I'm going to go over before I'm just going to go through a quick test of showing you how this works. Most likely going to crash, but you're going to be able to see what's going on in GDB. So this is just going to be one of the more making a vector from a vector. Const vector t other, and this is always going to be there's going to be the one with the ref, an actual value. We have to also, take in the one that has a value because sometimes you just want to compare by value rather, and you need to support both. Other dot reserve size and vector size is other dot vector size. Now, how you're going to do it from one vector to another is if you guess pasting exactly what I had, then you would be extremely correct. You take exactly that, except now, curiously, you're just iterating in the same way. You would think that you would do something a little bit different, just like maybe do some smart this equals that or something like that. But it turns out to be a lot simpler than that. You just other dot vector size, and then you plus plus I, and then all you're doing is new array plus I, and then t is simply other at I, because you're just going to be creating values with the values that are in those arrays. There's really no other reasoning behind doing it like this. It's just simpler, and I guess it's quite easy to understand and to read. Now, there are a couple of errors that I've written in, such as not writing the proper amount of closing braces for, I think, the majority of what I've written, but I'd say that it looks just about like it will compile, and this is the minimal part of it. I'll definitely be coming back to it. Now let's just write a quick makefile to make our lives easier. Let's see. All g++ g main.cpp vector.h -o test. Yep, that's what I thought. Emacs. I guess I have to look at VS Code. I'm just going to type exactly what I had in there in VS Code, simply because my Vim is not very happy with separators, and I honestly don't want or have the time to fix that right now. So I'm just going to show you exactly what I have, which is nothing different from what I wrote g++g main.cpp vector.h O is test, and that's it. VI into makefile, that's it. Very simple. So now let's create a quick main.cpp. So what we want to have is we want to include our vector, which of course is in quotes rather than angle brackets because it's a header that we've written ourselves. And just let's make a simple example. std vector int a5 is something that we could write in the STL. Now, oh man, let's go back. Now what we're going to write is instead we're just going to write vector int a 5. Then we're going to write vector int b a dot begin, comma a dot end. Then we're going to write vector int c 10, comma 3. And instead of int, let's make this a char, or let's make this a float, just 10, comma 3. And now let's make a secondary vector float d from c dot begin and d dot begin. Now let's return 0 and make. Oh, we haven't implemented iterators yet. That would do it. Completely forgot about that. Either way, let's demonstrate this instead then. GDB test. Let's break to enable. Let us break on line 5. Let's run it. So now let's go step in, and we have now started on a uint n because that's what we've specified, if you remember. We go next. If we print reserve size, it's become 5 in vector size. It has also become 5, or print vector size 5. We create the array. If we want to print what array is, it's that print star array 0 because we've reinterpret casted it to a int pointer. Now we do this 5 times, 3, 4, 5. There we go. I locals. Let's see. And now let's print A. A is a vector, reserve size 5, vector size 0. But if we print A 0, we haven't implemented bracket operators yet. That's fine. Print A dot array, and we print star A dot array. We get 0. Print star A dot array plus 3. Still be in scope. Yep, it's still there. But then if we try to go outside of bounds, array plus 5, for example, we get 0. We'll probably just still keep getting zeros. But the point is, it's working and we have our actual underlying data structure that's been created. Next, we go to print C, an array of reserve size 10, but now we check, hey, did it actually do what we wanted? C dot array is a float. Yes, that's exactly what we wanted. Print star C dot array 3. And remember, it's size 10, so print C dot array at 9. It should be 3. C dot array at 10 is no longer within the bounds, so that's an error. So we have something that works. We have something that actually has an underlying data structure. Next up, I'm going to talk about how to implement bracket operators, implement iterators, implement different vector functions such as pushback, find within a vector, which is really nice, pop back, different sorts of ideas for it, and later on, even implementing a string data structure quite simply on top of vector so that we don't really have to deal with most of strings inadequacies. I hope this was helpful, and I hope you learned something. I'm going to be posting the code pretty shortly on my GitHub. Thank you for watching. Have a great day.